is what I am talking. That is like first thing we are seeing today. There are two functions in addition. First of all, I can see f1 plus f2, right? So if you have the modules, please open the problem 1 of page number 6. This is an exercise problem. We need to find a domain here. So in this, they have given the function f of x is equals to square root of -1 into base 0.5 log base 0.5 minus x square plus x plus 6 we have, and then like after this we have in addition. Oh, minus is not there, just log. Okay then. Just log only with it. Then minus in some other problem I have seen. Then plus 1 by x square plus 2x. So this is the function f of x. Now, as I have mentioned in the domain table, there are two functions in addition. First of all, we can see that situation. F of x is equals to f1 of x plus f2 of x. In this case, I need to find d1 intersection d2. That will be the domain of the function f here. Now the d1 is the challenging one here. A d2, if you want, listen, in d2 what you have, that is f2, right? For domain d2, if we are solving the given function f2 of x is equals to 1 by x square plus 2x. This is not difficult thing, right? If I see here, it is a reciprocal of a quadratic function. Like quadratic function is defined for all real values of x. Now what I need to make sure in this is like there is no restriction for x square plus 2x. X square plus 2x is defined for all x belongs to real. Since it is there in the denominator, I am stopping that x square plus 2x to be 0. Right? So next, this is x into x plus 2 is not equals to 0. That means x is not equals to 0 and x is not equals to -2. Right? These two values we should not have in the domain. Right? So if you want d2 here, d2 is real numbers excluding -2 and 0. No problem. Remaining things. Right? Now, if we are taking D1, D1 is the trickier one and the challenging one as well, right? So, now let us solve for D1. For the D1, right? So, I can see function f1 of x is equals to square root of log base 0.5 minus x square plus x plus 6, correct? Right? So this is the function given, right? In f1 there is a square root function and then there is a log function. Now two things I need to make sure. First is log base 0.5 and then minus x square plus x plus 6 is strictly greater than 0. Second thing here is minus x square plus x plus 6 is also greater than 0. Right? Now here I have given in logarithmic inequalities two cases. Base is greater than 1, direction won't be affected. This is the second case. Base is yes, equal to 0. And this is the case when base is there in between 0 to 1. Decreasing function, you need to write minus x square plus x plus 6 is less than or equal 0.5 power 0. 0.5 power 0 is 1. So we should write minus x square plus x plus 6 is less than or equals to 1. So minus x square plus x plus 5 is less than or equals to 0. X square minus x minus 5 is greater than or equals to 0. Now solving here is not easier. What we should do? Here we have a We cannot split middle term. Like first what you should do is find the roots of this one. Let us assume it is x minus alpha into x minus beta is greater than or equals to 0. Drawing a number line, identifying alpha and beta. Since it is an upward parabola, plus minus plus you will get, right? Now finding alpha and beta. For that the roots I can say x is equals to 1 plus minus 1 plus root 20 divided by 2 I'll get. So 1 root alpha is 1 minus root 21 by 2. Another root beta is 1 plus root 21 by 2. See, like I need to approximate to know exactly where these numbers lies in a number line. Root 21, if you see, it is in between 4 and 5. So 4.4 or something we can take. There is no problem in that. If I take 4.4, alpha will be approximately 1 minus 4.4 by 2. This is minus 3.4 by 2, which is approximately minus 1.7. Beta is again 1 plus 4.4 is 5.4 by 2 is 2.7. Right? So now drawing the number line, I am directly writing in this case, I'll get x belongs to minus infinity to alpha, closed bracket, union, beta to infinity. At the end, I'll write what is alpha and what is beta, right? So now one part I have solved. This is the second part I need to solve. In second part, I need to make sure minus x square plus x plus 6 is greater than 0. So x square minus x minus 6 is less than 0. This is x minus 3 into x plus 2 is less than 0. Again, same thing, draw the number line. One critical point is minus 2, another is plus 3. Take the values according to this. If you take less than, you will get positive, negative, and positive. This is valid if it is an upward parabola, or else you need to change the signs if it is a downward parabola. Right? So we can say here x belongs to minus 2 till 3. So now what we need to do is like we need to take intersection. For this only we actually approximated, right? So maybe like I am finding D1 here. I am not done yet. This is 2 and 3. First I am doing like intersection between 2 and 3. I will get D1 here. This implies, listen, like it is starting from minus 2, right? So I am taking minus 2 till alpha value is minus 1.7. After minus 2 only we will reach alpha. So this will be equals to, I can say 1 minus root 21 by 2 closed bracket union, right? Again, it will start from beta. Beta value is 2.7 approximately. 1 plus root 21 by 2 till 3 open bracket. This is domain D1. Now you have domain D2. I need to take intersection. If you observe carefully, neither minus 2 nor 0 we have in the domain D1, right? This implies domain D is equals to minus 2 to 1 minus root 21 by 2 closed bracket union 1 plus root 21 by 2 till 3. See, like if you are having how I am writing this, actually I am drawing a number line. In the number line, I am marking all the intervals. Interval number 3, if I see, it is starting from minus 2 and it is going till 3. Open bracket, I will use a semicircle kind of thing, right? Closed bracket, I will use rectangle. Now it is like 1 is this side, minus 1.7 is somewhere here, and then like next is 2.7 is here. One says 2.7 till infinity. Now this portion is common. Another says minus infinity to minus 1.7. This is the common portion. Boundaries, I'm sure, minus 2 to alpha and then beta to 3. So alpha is there in both the intervals, so include alpha. Beta is there in both the intervals, include beta. Neither minus 2 nor minus 3 is there in the third interval, that's why we are not including. This is how I'll solve for common domain or intersection between intervals. Any doubts? Online students, any doubts? Copy then.
No, sir.
Today or maybe tomorrow, I'll post the notes in group. Okay. I'll keep everything in one place and I'll post what and all I thought in doubt class.
Sir.
Fully done. D2. D2 everybody done. Try second problem in the same exercise. If you copied everything in this, done. Same exercise. In second problem, what is there? Square root. In square root, there is minus log base 0.3 and it is x minus 1 divided by inside again another square root x square plus 2x plus 8. See, like here, what I observed when students solving this problem, na, whenever they have something, a function f of x divided by g of x, they'll break this one into two things and they will say in this f of x is greater than 0 and g of x is greater than 0. Maybe some will include equality here. But what I am arguing, I am saying this is not incorrect, but this is not accurate. Only one case you are considering. Like you imagine a situation when you are dividing two numbers. Real number A divided by real number B is positive, implies that both A and B are positive or both A and B are negative, right? So like here again, this is one case, or you can also say that f of x is less than or equals to 0 and g of x is less than 0. What I say, instead of breaking in this way, take them as two functions and then solve as a single inequality. Now I have an inside square root thing. I am writing log minus 1 into log base 0.3 x minus 1 divided by square root of x square plus 2x plus 8 we have with us, and then like this should be strictly greater than or equals to 0. Like you observe the denominator, it is a square root of something. We know that square root of something will be always positive, right? It is not going to create any trouble to us, so I am sending the square root to another side. I made sure it is positive, so I am sending. If there is a negative situation, then I'll try to break them. I try to factorize them. After factorizing, I draw a number line and I will do by Wavy-Curvy method, right? Here, the denominator is always positive. From there, I can write that minus 1 into log base 0.3 x minus 1 should be greater than or equals to 0. Now, one more thing I need to make sure. I have something inside a square root here. That is like x square plus 2x plus 8. This should be strictly greater than 0. Equality can't be used because it is in the denominator. Now from here you solve this. You have log and then x minus 1 less than or equals to 0, right? Now I think I have mentioned something like this. Now only it came to my mind. When I am changing sides for this, base 0.3 direction will be reversed. X minus 1 is greater than or equals to 0.3 power 0. Right here it is not required to put x minus 1 is greater than 0 because we are solving for a situation where x minus 1 is greater than or equals to 1. This implies by default x minus 1 is greater than 0. No need to consider it. When you have x minus 1 is less than something, right? Like in that case, this side I said in the inverse trigonometric function, please add 0 less than. Clear? Let's say you have x minus 1 is less than or equals to 4. You are considering negative as well. So you should put 0 less than x minus 1 less than or equals to 4. So here it is not necessary. So we are writing x is greater than or equals to 1 plus 1, 2 here. Now, second thing, what is my claim on second one? If you observe, the second quadratic equation does not have any real roots. If the quadratic equation does not have any real roots, it is not going to intersect the x-axis. If it is not intersecting the x-axis, f of x or the quadratic equation is not changing the sign at all. Clear? It will be always positive sign. I mean, this is your y is equals to 0 line. Y is equals to x square plus 2x plus 8 is not intersecting. It is lying above. That means it will be always positive. Above the x-axis, y value is positive. Below the x-axis only, y value is negative. Unless until it is cutting and then coming below, you don't have negative values for the quadratic equation. That means it is true for all x belongs to real. So next to this, whatever x value you put, this inequality is always true. There is no restriction. No real roots implies In that case, the discriminant less than 0, no real roots. In that case, it will be always positive or always negative, depends on the sign of coefficient of x square.
So and downward, then it will go.
If it is downward, if it is a downward parabola, roots are imaginary. In this case, if you see, no part of the parabola is lying above the x-axis. If it is not lying above the x-axis, that part is not positive. There is no portion in the parabola where it is positive. If it is not there, this inequality is not valid. You should write x belongs to pi. Clear?
Because it's greater than.
Always greater than 0. Clear?
That is greater than or equal to 0.
Equality won't be there. Inside denominator, no, it is in denominator.
But inside root only.
This is f, this is g. G cannot be 0. That's why only I'm not saying it. If it is 0, denominator you are writing 0.
Okay.
Right. Understood? Now only one thing you have, that is like x belongs closed bracket to infinity open bracket. This is the topic. Understood? Next we will see some problems on range as well.
So if it involves trigonometry,
There.
the coefficient sign cos.
Try now once, then you will understand. If it's sine cos, domain is real numbers only. No problem.
Directly apply that in the.
If it is there inside root, then only you should think once. If it is not in the root, no need to think. So like next we will see about range. In range like this, we don't have any approach table, we don't have any techniques. What we use is like some standard things are there. For this function, we will use this, like that we don't have. What we do is like we use differentiation, or we use this increasing decreasing nature, and we find inverse of the function. From there we find domain of f inverse, which is range of f of x. Clear? So these main techniques we have. Other than this, like if some standard functions are there, quadratic is there, completing square method we will use. Then if it is like linear by linear or quadratic by quadratic, something like that is there. In that case, we use another technique that we will see now.
The fourth question.
Hmm.
What are the conditions we should take?
What is the fourth question?
In ninth question, fourth confusion.
That's what is the fourth question? I didn't see it yet. What you are thinking of using?
X plus 1 by 2 is greater than 1.
Why cannot it is greater than 0 and not equals to 1? Base can be 0 to 1 or greater than 1. It cannot be equals to 1. Second thing, what you are saying?
That's what.
It can be. You have no log base 0.3. What's wrong in that? So like with some examples, we are learning how to find range. So like this first example, what we are seeing is like when we have linear divided by linear. When you have linear divided by linear, what we actually do in this, we find inverse of this function and find domain, right? This is the case. Finding f inverse x. From there, we will find domain of f inverse. Using the domain, we will write range. Now, we will take f of x is equals to ax plus b, maybe instead of a, b and all. X plus 1 by x minus 1. So next to this, I'm writing x belongs to real excluding 1. So we are finding inverse. I have mentioned you assume y is equals to f of x and solve it and get x is equals to f inverse y. Once you do this, you have f inverse y. In f inverse y, interchange x and y, you will get f inverse x. F inverse x is there, find domain, right? So now I am saying y is equals to x plus 1 by x minus 1. Now cross multiplication x into y minus y is equals to x plus 1, right? Writing all x things in one place. This is x into y minus x is equals to y plus 1. Now we can say x into y minus 1 is equals to y plus 1. So we get x is equals to y plus 1 by y minus 1. Now you have here x is equals to f inverse of y. Now we can say f inverse of x is equals to x plus 1 by x minus 1. Now domain of f inverse is also equals to a range of f of x, which is range of f of x. Now in the domain, if I observe, that is like real numbers excluding 1. Same we got, huh?
F of x is the range of the.
Same function we got. Then function and then inverse both same.
Then equal, then range of f of x. When domain and range are equal, then.
No. Domain of f inverse will be same as range of f of x. See, there is a function f is working from set A to set B. F inverse will do opposite. F inverse will work from B to A. So the domain of f inverse, which is B, is a range of f.
So is this an identity?
No, not identity. Why identity? Identity is f of x equals x.
We get the same as well. I mean,
There are some functions whose inverse is same. Composition you do here. In inverse you learned G composition f is equals to identity. Then you say G and f are inverse to each other. Now you do f composition f here, you will get identity function. Clear? Now we copy this in general. I think I can give as a formula here. Then if you have a function like this, in that case, domain is equals to real numbers excluding minus d by c. And range is equals to real numbers excluding a by c. This you can read as a formula. Now in a case where you have second example you take, this is when quadratic by quadratic or quadratic by linear you have. In that case you can use this method. We are taking f of x is equals to x square minus 1 divided by x square plus 1, a simple quadratic I have taken, right? So this is valid for all x belongs to real, no restriction in the domain you have. Denominator will be always greater than or equals to 1. No need to worry about 0 here. So now, as I mentioned, this is valid only for quadratic by quadratic or quadratic by linear. You have y is equals to x square minus 1 divided by x square plus 1. We again multiply them. Now here we won't find the inverse, we get a quadratic equation here. So this is y into x square plus y is equals to x square minus 1. This becomes y minus 1 into x square plus y plus 1 is equals to 0. Now you have a quadratic equation in variable x, right? So take two cases. Case 1, y minus 1 is not equals to 0. Assuming that it is a quadratic equation, then only you can solve after this. There is some real values of x and real values of y as well. If there is real values of x and y, this quadratic equation should have real roots. Clear? Understood? Like in this equation here I am speaking, there are some at least one real value of x and y as well. So if at least one real value of x and y we have, this equation over here, this quadratic equation should have real roots that can be equal or that can be distinct. So discriminant is greater than or equals to 0. Discriminant you see that is 0 minus 4 y minus 1 into y plus 1 is greater than or equals to 0. Now I get y plus 1 into y minus 1 is less than or equals to 0. Like here directly I am not writing like y belongs closed bracket minus 1 to plus 1. I am writing y belongs closed bracket minus 1 to 1 open bracket because I assumed this one as a quadratic equation. If y is 1, that cannot be quadratic equation. Discriminant won't be there if it is not a quadratic equation, right? So next thing in case 2, right? I said no, y minus 1 is not equals to 1, 0. What if y minus 1 is equals to 0? Do I have a real value of x for the image y is equals to 1? Do I have a pre-image for the image y is equals to 1? For that, you substitute y is equals to 1 in any of the equation. You can do here or you can do here as well. Now you will get, the moment you put y is equals to 1, you get 1 is equals to x square minus 1 by x square plus 1. Now interchanging this, I'll get x square plus 1 is equals x square minus 1. Both sides x square is getting cancelled. 1 is equals to minus 1. This is a contradiction. So we got this contradiction or we got this one because our assumption is invalid. What is our assumption? Y is equals to 1. So y cannot be equals to 1. Therefore, the range is closed minus 1 to open 1. Understood? Any doubt in this? Copy this, please. This concept or this method you can use if it is quadratic divided by quadratic. I think quadratic by linear, we will use the long division method and we'll factorize it. Done.
Close.
So next, when the function is defined in the closed interval, when the domain of the function is closed interval, in that case we will find it using differentiation, absolute maxima and absolute minima. Can I scroll? See, this method you guys can use if the function is, domain of the function is closed interval. Right, done everybody? So like, I think I have thought something like this in a problem, but not as a concept I remember. Like when I have a function, f is defined from closed A to B till C to D, it can be closed, it can be open, something like this you have, right? In this case, you can find the range using the differentiation method. That method is your absolute maxima and absolute minima method, right? In this method, in step number 1 of this method, you differentiate y is equals to f of x and find dy by dx or f dash of x. This is the step number 1, differentiate it. In step number 2, equate the first derivative to 0. F dash of x is 0. If we are doing f dash of x is equals to 0, there may be some values x1, x2, x3 and so on going till xn. N solutions it has, let's say, right? Out of this n solutions, consider only the solutions belongs to the interval a to b, right? So now x1 and x2 belongs to A to B, remaining are not there in A to B. In step number 3, what we need to do is like, we need to find the values of f of x, find f of A, find f of x1, find f of x2, and then f of b, right? So now small m stands for minimum between the above things, that is f of a, f of x1 and so on. You take f of b, minimum out of that 4. Capital M stands for maximum out of those 4, f of a, f of x1 and f of b. Now the range of the function f of x will be equals to small m to capital M, the bracket is both sides closed. You have a problem in the exercise in range, problem number 10 of the same exercise, where you need to find a range of eighth subdivision of 10th problem, log base 2 root x minus 4 plus root 6 minus x we have. That function a range we need to calculate. Can I scroll up?
Yes.
See, in some situations, while finding range, we will find the domain to get some idea about the function, right? So like the given function, if I see in the same exercise, 10th problem, 8th subdivision, function f of x is equals to log base 2. Inside log base 2, we have x minus 4 plus 6 minus x we have with us, right? Now x minus 4 and 6 minus x are there inside square roots. So by default, both should be greater than 0. Then only the log is then only it is real, or else you will get imaginary there. So making sure x minus 4 is greater than or equals to 0 at the same time, 6 minus x is also greater than or equals to 0. Now you have x is greater than or equals to 4 and you have x is less than or equals to 6. Maybe if you didn't understand, multiply -1. And then write x is less than or equals to 6. This implies x belongs to 4 to 6. No need to worry about log function because both of them are square roots. Square roots are positives. Again, both simultaneously is not going 0. That also you can check, right? So once you have the interval, it is a closed interval. Whenever you are finding range in a closed interval, you differentiate the given function f dash of x. I'm using chain rule. Initially, it is a log function. Technically, I cannot differentiate log base 2. What I should do here is like I should write log base e. I should convert it into log base e. Then only I should differentiate. But here it won't matters actually. So I'm differentiating normally. See, like maybe I don't know whether you have seen earlier or not. Log e base x. If you are differentiating this one, you will get 1 by x. But if you have log x base a, differentiation is not equals to 1 by x. You need to change the base. Using change of base theorem, you should write like you will get 1 by log a base e into x. This is the derivative of other bases. Here it won't matter. Anyway, it will go to other side. So I'm not writing it. 1 divided by root x minus 4 plus root 6 minus x into. Now I'm differentiating inside a square root function, chain rule. If I differentiate, I'll get 1 by 2 root x minus 4, right? Again, plus 1 by root 6 minus x. There will be a -1 with us. This is the derivative. My intention is not to differentiate or not to get this value like quickly I'm doing. We are equating this to 0. If we are equating this to 0, first bracket I'm sending as such to right hand side, it becomes 0. The second bracket we have 1 divided by 2 times of root x minus 4 minus 1 divided by 2 times of root 6 minus x is 0, right? So now simplifying this, come out online student.
Yes, sir.
Where please?
Sir, log to the base e should come in denominator now, sir, after differentiating.
You want, we'll write here. If we are changing sides, it becomes 0. So
Okay,
after
sir.
simplification, what I'll get here is like I'll get root 6 minus x by root x minus 4 is 0. Remaining everything, I change sides with 0, they multiplied, you got 0. Now 6 minus x is equals to x minus 4. So you have 2 is equals to 2, one moment, not 2, this is 10 I guess. 10 is equals to 2x, x is equals to 5. So only one you got and that one is the point of the interval. Now what you should do is, you should find how much is f of 4 value. The moment we substitute x is equals to 4, root 4 minus 4 is 0 and then root 6 minus 4 you do, that is root 2. So we are writing this is log 2 power 1 by 2 and base 2 we are getting 1 by 2 here. Now similarly f of 6, if we do, the moment we substitute x is equals to 6, root 6 minus x is 0, 6 minus 4 is 2, again you will get here log 2 power 1 by 2 base is 2, this will be equals to 1 by 2. The last one, that is f of 5. F of 5 is equals to, the moment we put x is equals to 5. 5 minus 4 is 1. 6 minus 5 is also 1. 1 plus 1 is 2. You have log 2 base 2. Right? Log 2 base 2, this value is 1. Now out of these three, maximum is 1. Minimum is 1 by 2. So the range is 1 by 2 comma 1. Clear? Using this method, we found out even though the brackets are open bracket, let's say 4 is open bracket or 6 is open bracket. In that case, I cannot include the minimum value 1/2 in the range. Clear? Since it is open bracket, I am not including it. Can copy this. Any doubts, online students?
No, sir.
Thank you. Today, maybe tomorrow, not today, I'll arrange all these things in one page and I'll post in the Teams. The size reduced or normally this much only till screen this much only, yeah? I think I have told I will start some classes. So many students are asking complex number. I don't know, you are all fell in love with complex numbers. So I will teach complex numbers only. The class schedule, I'll check my schedule and I'll let you know. Clear? Complex number, not from scratch, please. So at least you read NCERT. You have in second chapter. State board you have. CBSE in 11th grade it was. In 11th grade you would have seen.
So, but on the whole, we don't use any classes.
Which one?
Combining 11th and 12th, state board and CBSE.
I didn't find anything like that. You tell me any chapter which you didn't studied in.
Statistics we had in 10th.
Not neither in 11th nor in 12th. Then you study from NCERT or this book.
We had relations. We had relations and functions in 9th, 10th, and 11th. Not in 12th.
You already studied, no? What I am teaching now. 1 on 2, right? Types of relations also you would have seen. The application problems may be new for you, not concept. Then you would have seen this continuity and differentiability, no? That you have seen.
Yes.
Then there they didn't thought about limit.
We did have
This boy telling you don't know anything about limit.
very small amount of.
Okay. You have seen this differentiation integration in 11th.
Some basic only.
The basic problem. Here we will teach.
Sometimes we use out for choice.
Okay, that's up to you. Whatever you have in your textbooks, at least some basic you would have seen. Right? think this much only. We have only 5 minutes after this. Solve the problems. If you have any doubts, you ask. Class will be either on Saturday or Sunday. I'll definitely post a message in the group, or maybe you check Saturday and Sunday as well. Timings.
Yes, sir.
If nothing is allotted, no need to message. There is no doubt, please. Right. That's what I should be available. No, this Sunday I have 3 classes. So if that 3 classes are like morning, it is finished, I can plan in the afternoon. In between that classes, I don't want to schedule. Saturday, maybe I don't have any class. That day I'll plan.
Shift to 70%.
What is that?
Types of functions, sir.
What you did there? Step 2, 17 fun.
Filling with attributes. First,
One more thing, cubic equation is there. No, write one note here. This is range for all odd degree polynomials. Let's say function is defined real numbers. Codomain is also real numbers. F of x is equals to odd degree polynomial. I hope everybody knows what is odd degree polynomial. Cubic polynomial. For degree 5 and so on. A range of this one is always minus infinity to plus infinity. All real numbers.
that f of function 3,
Hmm.
how to prove that
That is
into, sir?
into a onto a. Into ಅದು onto இல்லையா? X plus cos x only no. See, there are two functions. Cos x is always in between minus 1 to 1. So about range, the unbounded function x will decide. Even though you are at infinity, cos x will be in between minus 1 to plus 1. But x is at infinity. In comparison between 1 and infinity, infinity is bigger value, 1 we will eliminate, or we will, what you say, discard it. We won't consider it. Very, very greater than, neglect it. So the range is minus infinity to plus infinity. To prove it is 1, 1, we will prove it is increasing. Increasing or decreasing, differentiate f dash x will be, I think, always greater than or equals to 0. You will get.
Sure. For a relation to be transitive, it's necessary that it has to be symmetric as well.
Not necessary. You have some relations which are only transitive, not symmetric. Anything else? If no doubts, dear online students, you can take break and join the next class.
Sir,
Yes, please. Your friend is asking. Yes,
Sir.
dear Hariharan J.
sir, I have some basic doubts, sir, like inequalities and the number lines, sir. What chapter I have to watch to understand this easily?
Basics of mathematics of 11th grade.
Sir, that is not in my state board syllabus, sir.
No,
Which
you
chapter?
watch in iTutor.
Which
Sets
chapter?
and sets and then inequalities in Akash 11th grade. Clear?
Okay.
Hmm.
And inequalities, sir.
Inequalities இருக்கும் அதுல இருக்கும்.
Okay, sir. Thank you. Is 2 chapters is enough for to understand this, sir?
Inequalities, if you want, there they will be teaching you in Wavy-Curvy method.
Okay.
That will be enough for you. Don't
Okay.
worry much.
Okay.
Polynomial are like this. Rational inequalities, they'll concentrate. About log and then remaining things. Like this, one property will be there. You should learn. Today I have given no.
I know some basic logarithms, sir. So this is not my doubt. I have doubt only in the inequalities.
Okay. As I mentioned, you watch that basics of mathematics thing. There it will be there, inequalities.
Okay, sir. Sir,